Introduction to Invertible Functions. Let's review what we learned about functions in the previous set of videos. A function is where each input only has one output. And when I state that, what I'm looking at here is on the left, this left set here, A through E, I have a series of outputs going to this yellow set, -6, 3, and 2. Each input only has one output going out here. A is only going to -6, B is going to 3, C is going to 2, D is going to 2, E is going to 2. Now, 3 of them are going to 2, but each individual input only has one line going out. On the right here, A is going to -6, B is going to 3, C is going to 2, D is going to 2, and 5. This is not a function because I don't know which one D is going to be output 2 or 5. If we look at a parabola y equals x squared, which we've done many times, we can use the vertical line test. That vertical line only passes through the function at any point once here. No matter where I move this line, it could be here, it could be here, and I know these are not terribly straight lines here, but you're getting my point. It only passes through it once. And when I look at this as a input set with x and output set of y, while one input here goes to 1 and -1 also goes to 1, that's all right because each input only has one output going. However, if we reverse this, instead of y equals x squared, x equals y squared, we get this sideways parabola. And it does not pass the vertical line test. It passes through 2 points, as I've circled here as well as here. And anywhere along this, it's going to pass through 2 points. And again, when I graph this, if x is 9, y goes to 3. Or if x is 9, y goes to -3. We don't know which one it is because I've got this 1 here going to 1 and -1. This 4 down here going to 2 or -2. And this 9 here going to -3 or 3. Again, not only graphically, but as well as algebraically, we turn it's not a function because we don't know which way it's going. Now, these are both equations, y equals x squared and x equals y squared. But the inverse of y equals x squared as a function of x equals y squared, again, by both equations, not both are functions. To be invertible, you have to reverse the input and output, and it still works as a function. On the left here, this is not an invertible function because y equals x squared, x equals y squared. While this is a function right here, I can use the vertical line test. This is not. All I've done is reverse the x and the y. But on this exponent right here, y equals 3 to the x, or I inverse it, x equals 3 to the y, these are both functions. Vertical line test, it will pass through only 1 point no matter where I'm looking at. And that means it's an invertible function. Now, how do you know a function is invertible? We can look at a table here. In general, as I stated here, a function is invertible only if each input has a unique output. And that has to go in both directions. Now, I've got this table here with x and f of x, where you can see here's a goes to -6 right here. I've also got c going to -6 and e going to -6. And that by itself is a function. But when I reverse this, all I've done is turn this back around here. You can see I've got 6 going to A or C, right here, A or C or E. So this is not an invertible function. This is an invertible function. I've got a unique input and output going in both directions here. A goes to 36 on the left here, B goes to 9, C goes -4, D goes 49, E goes 25. And if I reverse this, it also has one input going to an output. So this is an invertible function. Each input has only one output. This is basically written. This is A, that's my input. Here's the function, and it goes to B. To be invertible, that B has to have the inverse function and goes back to A. This is not, while this is a function right here on the left, because I've got each one of these has only one input going to an output. They both go to 2. But when you see it, and when I inverse it, now I've got the 2 going to 1 or 3. I can't decide which one to go to. So it is not invertible. This is invertible. 1 goes to X, 2 goes to Z, 3 goes to Y right here. And when I reverse this, X goes to 1, Y goes to 3, Z goes to 2. So this is an invertible function. We look at this table. And you can see I've only got one input going to one output at each one of these. And when I inverse it, I still got one input going to one output. We basically, I should say, when we have an inverse function, we can write it like this. The original function is x to f of x. And when we inverse it, x to f to the negative 1x. It's not, that negative 1 is not saying it's a fraction, or as you say, a rational function. That's just how we state it. Now let's look at this one. Is this an invertible function? And before we go any farther, you can already see the pattern here. While this is a function on the left here, because each input has one output, you can see right here, before going farther, when I inverse this, that negative 2 is going to go to 5 and 8, and we don't know which one it is. So this is not an invertible function right here. And f of x equals x squared, as we started at the beginning, you can see graphically why it's not an invertible function. When you use the vertical line test, it's passing through 2 points. So when I use 4, I don't know if the inverse of that is negative 2 or 2 here. So just because it's a function in one direction, if I have an invertible, it may not be a function in the other direction. And when I inverse it, it has to be a function in both directions. Now visually, how can you tell if a function is invertible? Well, basically, I've got y equals x squared. Now I've got 5 equals 25 right here. If I put 7 squared is 49, and I put 100, or 10, I get an output of 100. Now, if I put in the y result to make the new x, it looks like this right here. Not only does that pass the vertical line test, when I put in, right here, 25 for y, I'm sorry, 5 for y, right here. 5 for x, excuse me. I don't know if no, it is 5 for y, screwed up here, sorry. My 5 for y, and I get 25, but I don't know if I should put, negative 5 gives me 25, negative 5 squared, and 5 squared. Same thing as when I put in 7 on y right here. I don't know if that should be, and I get 49 here on the x-axis. I don't know if that should be 7 or negative 7, because they both cross that, doesn't pass the vertical line test. And then even 100. When I put in y for 10, I get 100. When I put in negative 10, I also get 100. So the question is, which one do I choose? I don't know. And that's why this is not an invertible function. Now in this exponential function here, y equals x cubed, I see 2. If I put in 2 for x, I get an output of 8. If I put in 3 for x, 3 times 3 times 3 is 27. Get output 9. 27. If I put in 4, 4 times 4 times 4, 4 times 4 is 16 times 4 is 64. Now, let's do x equals y cubed. So if I put in y for 2, I only get 8. 2 cubed, 2 times 2 is 4 times 2 is 8. If I put in 3, 3 times 3 is 9 times 3 is 27. I only get one output. I put in 4 for y. I get 64 for x. 4 times 4 is 16 times 4 is 64. So this is an invertible function. And, it passes the vertical line test right here. It only passes through one time. Now, where do we use invertible functions? There is a famous study in the early 90s called the Nun study. It was funded by the National Institute of Aging. Now, they did a study of nuns who were in a convent, and a lot of them were for their, since they were 18, 20, 25, and they kept diaries. They were supposed to keep diaries. And while the Catholic Church did not, or say this specific nun group did not want autopsies. They thought this was for study of Alzheimer's. It's for the greater good of mankind. So they allowed autopsies on the brain after these nuns died. And it was interesting. Like I said, they had their autobiographies. They had their history since when they were teenagers, a lot of them joined the convent when they were 15, 16, 17. And they're testing various things. And they did neuropathological evaluation. And what was fascinating is that higher cognition during aging, even if the individual nuns had brain lesions resembling Alzheimer's disease, it showed that the higher a volume of education someone had, the lower the likelihood of dementia. It's very powerful. It basically said, like, even if dementia is occurring, the more education someone had, because they had nuns who had never finished high school all the way who had nuns who had doctorates. And the more education they had, the lower likelihood of dementia, and less dementia if it was realized. And this a lot had to do with, as you get better educated, you have more and more neural pathways being created. So even if some break down during Alzheimer's, other ones get rerouted. And the more routes you have from better education, more knowledge, more studying, more neural pathways are created. And what they realized was this was an invertible function right here. Now, on this first graph here is x equals 2 to the y minus 7. I'm sorry, this one right here. And this was saying Alzheimer's rates per 1,000 in education levels. Right here are education levels. This would be, let's see, education, 12 equals a high school graduate right here. And a higher education they had, this was the rate per 1,000 individuals of Alzheimer's. Now, the education level resulting in Alzheimer's disease per 1,000, what they noticed here, and this is also education level, this would be 12, this is the average right here. And they realized the more education, the less likelihood of suffering advanced dementia. So this is an invertible function. The more the longer you live, the more likely you get dementia. But the better education you have, the less likely you get dementia. So very powerful study where we use invertible functions.